Hello and welcome back to Get It Set Tech. Today we have a vintage Sunbeam Mixmaster, service number MMA. It's a 175 watt model, and I would normally do a disassembly video on something like this, but there's a fellow on YouTube who goes by the name of Vintage Mixers and More, and he's already done an excellent disassembly video on this one. As a matter of fact, I used his video to disassemble this, and so I thought I wouldn't try to do another disassembly video. I can't top what he did. So instead, I thought I would show you a curiosity about how the speed control on this mixer actually works that I thought was interesting. The speed is controlled from this end of the machine here using this dial. The dial changes the speed from 1 through 12. And that's the off position there, of course. Now inside the dial is a ramp of sorts. The ramp ranges from thin here to thick over there. And this ramp is in contact with this screw here. The screw varies the speed of the machine. When it's sitting in the resting position here, the machine runs at full speed. When you push it in more, the machine runs at a slower speed. And so, since the screw rides on this ramp, it changes the speed of the machine from full speed to slowest speed like that. I'll try to get the dial on here to mate up, see if I can show you how it normally sits and how it works. You can hear a click when it gets to the off position. That's because it's contacting this switch here, and this set of contacts there opens up when you push down on the switch, and that turns the machine off when the dial's in the off position, and it just sits there like that all the time when it's not being used. So we are looking at the speed control here back at the end of the machine, and it consists of a few things. One thing is these contacts here that either make or break connection like that. When they have continuous connection, then the motor runs at the quickest, fastest speed. When they have the connection broken like that, the motor will slow down and would eventually stop. Except that there is 150 to 200 ohm resistor in series with these contacts, and that resistor would keep the motor going a little bit, but it can't do that for very long because the resistor would burn out if it was stressed out if you left it that way too long. So it's not designed to do that. We'll get into why. Now, over here, if you can see this, you can see a little bit of the motor here, and of course the fan blades to the motor. Now here's this curious device here attached to the fan blades of the motor and really to the armature of the motor. This is a mechanical flyweight assembly that works on centripetal force. Whenever the motor's running fast, these are the weights. They're not very heavy, but these are the weights that tend to want to move outwards because of centripetal force. And because of that force, it will tend to pull this whole assembly outward with these weights when it goes. Pulling the assembly outward is going to make it go further, squeezing itself, making the whole assembly thinner, which pushes the thing. It's linked mechanically to this contact here that I'm pointing to with my thumb, and it is pushing that contact away from this speed adjustment contact. See that? So motor runs fast, contact opens up, motor runs slow, and the contact resumes. So now, if you leave this assembly at rest, just like it is, these contacts will be in contact with each other the whole time. It'll be continuous, and so the motor will run at fastest speed. When you push that contact back like that, then it doesn't take as much force for this flyweight assembly to push that other contact away from it. It's a lot easier than it would be if you were pushing. See, I'm pushing now, and you really can't push it away because it's not designed to do that at the fastest speed. So here, this is the curious thing. When you push on this, that's meant to be slow speed. And so this flyweight assembly starts to go out, weights go out, pulls on this, makes it thinner, pushes the contact away, and so contact's broken, and the motor slows down. Motor slows down, centripetal force goes away, contacts resume, and the motor speeds up because it's got electrical power. Flyweights go out, stretches this assembly out, pushes on the contact, motor loses power, then relaxes and goes back, motor gets power, speeds up, flyweight go out, stretches out, blah blah blah. It repeats itself very rapidly. I'll set it up here so you can see the action, but you won't be able to see how rapidly it's doing this. So rapidly you can't really see anything but a spark here that will form. And so this thing is being controlled by a variable duty cycle regulator, and that is the sum of this assembly here. Regulator consists of these points, this flyweight assembly that rapidly makes and breaks these connections to create a variable duty cycle control, anywhere from 100% duty cycle at full speed to a much lower duty cycle at the slowest speed. And this is an ingenious invention from years and years and decades past. They didn't have electronics to do this kind of thing, which maybe in some people's opinion, the electronics of today would have been much simpler to use. But they did what they had to do. They came up with a mechanical gadget, electromechanical, combination electrical mechanical, to do this. And so you can vary the speed of the motor by varying the duty cycle of these contacts that are constantly making and breaking. And so because of that, you're not using any real resistor to change the speed of the motor, because if you used a resistor, the thing would heat up. Nobody would like that. But this variable duty cycle switching doesn't create any heat. Okay? It controls the speed without any resistors, without any auto transformers, anything like that. And so here in a little bit, I will get this thing running and I'll let you see this thing in action. So here we go. I'll try to zoom in here, get some close-ups of this just because it's cool. And I'll also try to get a close-up of the flyweight assembly. You can see the flyweight assembly changing ever so slightly. It's hard to see, but and you can see the effect of it. It looks like inertia of that flywheel assembly taking its time to allow the contact to get back together. And that there is the on-off switch. The dial keeps it in place in the off position as discussed earlier. And I unplugged it. And of course these contacts, as I said before, are in series with the motor. But there is a resistor that is in parallel with these contacts, so that whenever these contacts are broken, there is now a resistor running the motor. But it can't do that for long, otherwise it'll blow out the resistor because it's not designed for that much power. So there is now a resistor in series with the motor, which is in parallel with these open contacts. And there is also a capacitor elsewhere that is in parallel with these contacts and the resistor. So these contacts and the resistor and the capacitor are all in parallel with each other. But the purpose of the resistor is not to knock down the power so that the machine runs at slower speed. That resistor is just not powerful enough to handle that. If you had these contacts open for extended lengths period, then the resistor would blow because it's not designed to handle that much power. The purpose of that resistor and the capacitor is to try to reduce the amount of sparking that these contacts have to handle so that they don't wear out quickly. Okay? So if you see a resistor in there, the purpose of that resistor is not to knock down power to the motor, but to reduce sparking at these governor points here. Okay, here we are. I'm going to temporarily install this dial such that we can regulate the governor using this screw here. Looking at that screw, it has a little opening in it That opening takes a 5/64 inch Allen wrench to adjust it, and it fits in like that, ready to go. When the dial is on, we'll be putting that 5/64 inch Allen wrench through that hole there that you can see. And if the dial is lined up just right, we will hit the screw behind the dial there. So I will fit this in place. I'll put the spring washer on. And the screw and flat washer. I'll tighten it up all the way. I don't want to fudge it because then the calibration would not be valid, because the dial is not riding that screw inside, that adjustment screw, in the right position. So now that that's in place, I need to adjust the dial here, not to the off position, but to position number 1. If you can see that. I've got position 1 dialed up. And if I did it right, I should be able to get this Allen wrench into that hole, begin to calibrate this governor. So I'm searching for it. There, I believe I found it. So I'm going to plug this mixer in. First I'll move it this direction. Now my Allen wrench is engaged, and what we're looking for is to get that tissue there to rotate about 4 times per second. It looks like it's pretty close to that right now, but I'll just show you the effect. I'm turning it to the right and it's faster. So now I'm going to slow it down. By going counterclockwise. Okay. That looks like about 4 times per second again. What I'm going to check is that when I turn the speed lower than 1, going towards the off position, I want to make sure that that doesn't get too slow. Okay, there's off. It shut itself off. And what I don't want to happen is to create any place on the dial where this machine runs too slowly. If it starts to run agonizingly slow, then that can burn out that resistor in there, because all the burden is on that resistor and it will burn out. So I want to make sure that anywhere the knob is, that the machine isn't going to run at an ultra slow speed. That is an ultra slow speed, and I do not want that. So I'm going to give it a little bit more clockwise rotation here. And there we go. Now, back to dial off. It is turned off. I turn it on. And immediately, even though it's not exactly at 1, it's going about 4 times per second. So I'm comfortable with that. And I don't smell anything coming from the resistor. So I think we're good. I forgot to mention at the beginning of the video that if you don't have an electrical background, this video may not have been of much interest to you, but if you do, hopefully you found this to be interesting. I thought this was a hoot to see this thing in action like that, and to see how people back in that day came up with solutions like this to make things work no matter what, and a reminder of times gone past. If you do like this video or any of my other videos, please like and subscribe. Thank you.